Hi, my name is Zach. I'm a local student here in St. George, Utah, and I've got the good fortune to be here at the St. George Dinosaur Discovery Site. And working as a student, I'm very fortunate to have any exposure to any of this stuff. There's so many cool things going on here. This whole region is just filled with an incredible amount of information and signature of ancient environments from a range of timescales. And much of that is of the time during the Mesozoic where dinosaurs were around. Now, because of a number of different factors, there's not a lot of actual fossils here, but there's other signatures. In the case of the St. George Dinosaur Museum, we've got an amazing array of what are called trace fossils. And so it's a whole series of fossil footprints and fossil impressions, leaf impressions. There's an evidence of an old lakeshore, fish remains, and this is just one little site. This is just one little window in time to a wild story over the past 500 million years of evolution here on Earth. So these are just some examples of what we have. Most of this is from the US. Some of these are replicas, some of these are real. This is Diabloceratops. Some other things here, Allosaurus replica. These are some of our local plant specimens. And the plants, including petrified wood, are easily dismissed as not as attractive and interesting as the dinosaurs, but again, we're talking about signature information. What can we learn about ancient environments? You know, learning about dinosaurs and the megafauna is one thing, but parsing out finer points of the story to understand what did it look like? How do we even wrap our mind around time frames when we're talking on 200 million years? So that being the case of our local stuff here at the museum, our traceway, 225 million years old. So Triassic, Jurassic boundary. A particular favorite of mine is this one here. Now this is the tip of a pubic bone of a sauropod called a Podosaurus. And this is interesting because you can see these marks here on the bone. And another overlooked component of fossil collections and seeing replicas and seeing material like this in general is looking at what research actually happens. So there's the aspect of educating the public and protecting the material once we find it, and allowing people access to it, whether that's people wanting to simply look at and enjoy the material, or hard research, hard science, looking at really what was going on with these animals, the environment, and how things have changed over time. Why this one is a personal favorite is because of these marks on here. And there was this wonderful paper that came out by Drumheiler and others in 2020. And this basically, which looked at this original fossil, again, this is a replica, looked at this fossil and did a quantitative analysis. So they basically did a mathematical treatment looking at the marks, tooth marks, on bones of dinosaurs during this time. And what they found, and what their interpretation rather was, is that during this period, so we're talking late Jurassic, so in the range of 150 to 155 million years here in central Utah and throughout the western US, seasonality was increasing. And so what they found in when they looked at the numbers, again, they're going through hundreds of bones of different types of dinosaurs, and they're quantifying, they're counting and measuring the marks, whether that's tooth marks, scratch marks, on all these different dinosaurs, and then looking at the math there. What they came to when they combined that with the changes in the depositional environment was that during this time, seasonality was increasing. Up to this point, for the dinosaurs that were persisting at the time, they were not as equipped for the seasonality. So talking dry seasons, wet seasons, hot seasons, cool seasons type of changes. And so seasons, the dry season, was becoming increasingly pronounced. And what their interpretation was is that allosaurs were resorting to scavenging and cannibalism on each other, which is particularly unique. And that starts to get at some of these finer details of What were these animals doing? What caused them to follow different evolutionary trajectories? And to see studies come out that really put some hard numbers and really start to look at the raw probability of our interpretation of what was happening, this is a powerful piece. And so they also included this wonderful image to help illustrate what was going on. And so here's some of the different dinosaurs, Allosaurus and Ceratosaurus, during this time, resorting to cannibalism and scavenging. And again, I mentioned this being a pubic bone, so this is literally under the pelvis, the hindquarters of the animal. So this is not a piece that would typically be exposed for common predation. So it was perplexing, I'm sure, to the first individuals that looked at it, why there was such significant bite marks from, thought to be from an Allosaurus, here on this underquarters of the animal. But it's reasonable to put together a picture of an animal that's died, a large, long neck Apatosaurus that's died. Its carcass is bloated, it's rotting, it's turned upside down, its belly's exposed, and these starving Allosaurs and Ceratosaurs come along, stressed from the increasing dry season, and start scavenging, and start resulting to cannibalism. So that's just one example of the amazing stories that we can pull out, not only of the time period, not only of regions and environments, but also of individual animals. There's so many great things happening in paleontology, from trace fossil studies, ichnofossils, such as the footprints that we have here, to plants, where we've learned so much recently in the paleontological community about plants, and that's informed us greatly on how climate change works in a long-term context, and paleopathology, animals, dinosaurs suffering from injuries, from diseases, from cancerous growths and tumors. It's just endless. So very grateful to be here, and I would recommend anyone in the area to definitely stop by and check out the material.